Hopefully. All right, so I only have one screen available to me right now, so I'm going to be looking at the presentation. I'm not going to be seeing anyone, so please raise your hand or just feel free to interrupt me, interject. Also, I was going to say that was a great presentation. I think mine is a lot drier. There's a lot less imagery and cultural references, but we'll get through it. All right, so sharing my screen. All right, can you guys see it?
Yeah.
Yes.
Okay, right on. All right, so today I'm going to present about Langchain.rb. A little bit about me. So I've been building software professionally for about 12 years. I built software for a bunch of these companies you see on the screen and many others. I've been running a small software development firm called Source Labs since 2017. And depending on the project size and the client size, I kind of play one of these roles, either an architect, an engineer manager, or if we're working with startups as a fractional CTO. So how did I get into this? We built quite a few kind of traditional keyword search applications, and I started diving into some vector search capabilities. I discovered the Langchain, the original Python Langchain implementation, and I figured that we ought to have a solution in the Ruby world as well. So I started hacking away on Langchain.rb, and it was interesting to me because after working in software development for 12 years, I've gotten so exhausted relearning a new JavaScript front-end framework every year or every couple of months. So this kind of presented new challenges and opportunities. So Langchain.rb, some high-level vanity metrics. So it's about 2 months old, 450 stars, 28 contributors, a few downloads. We have a small Discord community, and Langchain.rb is an orchestration layer. It's an orchestration layer. So you can see from the diagram, and I borrowed this enterprising looking diagram from A16Z blog. But when it comes to building,
know that we can't read. We can read the title of that slide. But if you want us to know what the little words are, you're going to have to tell us.
Okay, let me also send you the link to the presentation. Let's see.
I don't know if that will do any good.
Yeah, most of us aren't in the Zoom, and so we won't immediately.
Okay, got it.
Just read us the little words if you want us to know that. Thanks.
Got it. Yeah. So this is kind of an emerging architecture for building LLM, large language model backed applications. So you have an orchestration layer in the middle. You have an embedding model, which is either OpenAPI or OpenAI, Cohere, Hugging Face. You have a vector database in this top right corner. There's external APIs, the data pipeline in the top left corner, and then also a variety of things like LLM cache, logging, kind of prompt validation, basically the orchestration layer sits in the middle, so it glues a lot of those systems together. So why Ruby? Obviously, Ruby is trailing a little bit behind Python when it comes to AI, ML libraries and the capabilities. You know, Python is kind of probably number one in the whole research / academia vertical. So I thought that Ruby is not going anywhere, and Ruby is very similar to Python. It's written in C. There's a lot of obviously the syntax is very similar. There's a lot of kind of similar problems, concurrency, and any type for any of those libraries where Python calls into C bindings, Ruby can do that too, right? The Ruby wrapper can be easily rewritten as well. I think the Ruby ecosystem has a very healthy level of pragmatism. And I think this has been just drilled over many years, over almost 2 decades now by Ruby on Rails. Obviously, Ruby on Rails kind of being the Swiss knife, working really, really well for 90% of the different use cases, 90% of the applications. We tend to not reinvent the wheel. The whole kind of phrasing, like there's a gem for that, right? We look for open source libraries, we'll look for existing solutions instead of writing something, the same components over and over from application to application from scratch. Also, from my experience, folks that are really seasoned Ruby developers, they tend to have really good software development fundamentals. They tend to write really good code. I think they definitely lean into the Ruby language, and the language is very permissive in that sense. Whereas if you take Python and if you take Python and the folks that are mostly coming from, again, research, academic kind of backgrounds, I find that the good software development fundamentals fall by the wayside, and monoliths are also back in fashion. I think in this environment of kind of economic stagnation or contraction, whatever your personal opinion is, companies are looking at their OpEx. They're looking at their product architectures, and a lot of times it just doesn't make sense to operate a overly engineered microservices or serverless architecture. And I think from what I've been seeing, monoliths are kind of making a comeback. And also, I'll bring your attention to this visual in the top left, in the bottom right corner. And it's borrowed from this really good blog called The Rise of AI Engineering. And basically, there's kind of this API boundary between all the magic that the research folks, the data science folks produce, putting APIs on top of those services, and then full stack engineers kind of moving closer to those API boundaries, and now being more exposed to those AI concepts, tooling, infrastructure, chains and agents. So what does Langchain.rb do for you? So some of the use cases it tackles or helps you with, or semantic search, which is vector search, QA over documents, chatbots, and also the agents, which we kind of consider as to be experimental. Some of the other tools it has is prompt management, so being able to create prompt templates, save them, set different variables, etc. Output parsing, so for example, being able to ask specifically for a large language model to return JSON back. Every model has a context window limitation. So we do context length validation, we do data chunking, we help you parse and import files into vector search databases. We've got chat conversation memory, so being able to maintain the same conversation and then kind of revisiting it later if needed. Agent tools, I'll go into it, and also deeper active record integration, deeper integration with Rails. So what is vector search? So vector search is a way to find related objects that have similar characteristics using machine learning models that detect semantic relationships between objects in an index. A kind of first-class citizen of vector search, when it comes to vector search, are word embeddings. And a word embedding is basically a vector, an array of float numbers, coordinates that represent properties of the word. And when you think of vector size, it's the vector dimensionality. So when we say that the vector dimension or an embedding dimension is of size 4096, that's what we're kind of referring to. So it's basically an array with thousands of different float numbers. And that's how the large language models are kind of organizing the semantic meaning behind different words. So you can see this example in the bottom right corner. If our vector size was only had only two elements, so an array with two float numbers, and let's say those properties represented size and age, we would kind of cluster them in this way. But of course, when the dimension is in the thousands, it's impossible to visualize it. Next is sentence embedding. So similar concepts, a similar concept, but for the full sentences. And again, for dimension that's equal to 2, a two-dimensional vector. If we were to cluster different phrases, you would see that phrases that have similar semantic meaning are clustered together, right? So you have a cluster that's kind of that's a greeting, some sort of a greeting. You have a cluster here that expresses admiration for one's dog, and you have a cluster of kind of soccer fans. And within Langchain.rb, this is what we're calling our vector search LLM matrix. So we're basically saying that you could take any vector search database and you can use any LLM model, LLM provider, and use them together. So for example, you could take Google Palm and Pinecone and use Google Palm to generate embeddings to then store in Pinecone, and kind of a growing list of other vector search databases. So what are some of the benefits? So one of the benefits is it's a common DSL, a common set of APIs, which offers interoperability. Excuse me. And because of that, you have a reduced vendor lock-in. You're not just tied to OpenAI. You can, if you're building vector search, you could kind of swap out with a different provider down the road. I mean, things are moving so fast. Like whether OpenAI is going to maintain its leadership, GPT-4 being kind of the most powerful model is TBD. So because of that, you have optionality, and we're also saying that we're going to try to build in best practices into Langchain.rb, so that you're following those when you're building these applications with it. So let's jump into some code here. So you could see, in order to build out a very simple vector search, I would pick an LLM. And can you guys see the code on the screen?
Yeah.
Yes.
Okay, thank you. So you can see that I'm taking a Google Palm here, and I'm just instantiating this class and setting the API key. It's the same kind initialization, it's the same method signature for all of them. So you could use OpenAI or like I mentioned, Hugging Face or one of the several of the other ones. And then, so in this example, we're also using the Chroma vector search, and we're instantiating a connection to the Chroma database by passing it the index name, the URL, and also the LLM instance itself. So we have an option to import the data by just passing an array of text and corresponding IDs by calling add text on the vector search client. We can also point directly to files. So for example, I would declare a path to my PDF, my text file, my docx, and I would just say add data, and here's the paths to my files. You could also hook it into your active record model. So in your active record model, you would just declare the vector search, pass it the instance of a vector search, and call this upsert to vector search callback. And once you have some data in there, you could call similarity search to retrieve similar documents based on the query string passed in. And basically the mechanism kind of behind the scenes looks at that semantic meaning. So what are the entries in the vector database that have the closest semantic meaning to the query passed in? And you can also do the QA style querying based on the question passed in by calling .ask and passing the question in. So I really hope you can see this. Let me full screen it. Are you guys able to see this?
We can see it, we can't read it.
Maybe like stand up and walk to the TV.
Yeah, we can all get up and go over there.
That might help.
Perfectly fine if anybody wants to. Yeah.
Yeah, please feel free. Unfortunately, it's a recording, so I can't really zoom in on it. So you could see that I'm not going to play it. I'm just going to be kind of jumping over through the timeline here. So you can see that we're instantiating a WeV8 vector search database here. We're calling our index organizational documents. I mentioned you have to pass an LLM, so we're passing an OpenAI instance in this case. And we're creating a default schema. We're calling WeV8 instance.create default schema. And it creates a default schema just kind of to get you started as quick as possible. I'm passing a path to my, I'm instantiating this PDF variable here, and I'm passing a path to my my benefits brochure. It's actually a real PDF I've had since 2014. This is a real benefits brochure for a company I worked at some point. And then we're importing this file, the content of this PDF into the vector search database. And once it's imported, we can do the QA style querying I've mentioned earlier. So for example, you could see that I'm asking, what is the company's vacation policy? How much time can I take off? And it comes back with the company's vacation policy allows employees to take any reasonable amount of time off with pay. It was unlimited, basically. What are all the benefits offered? The benefits offered include medical, dental, vision, life, short, long-term disability. Tell me about the 401k benefits. The 401k benefits at this company allow employees to begin participating right away, ... How much does a dental plan cost? The cost of a dental plan depends on the coverage level, ... So it's able to find answers to all of the different questions that I'm posing. And go ahead.
So I'm trying to figure out why we would do this. At work, I'm pretty sure we use embeddings, which I think that word came up earlier, to give ChatGPT more information than will fit in a prompt.
Mm-hmm.
Is that what this is doing?
So for the QA style querying, so what we're doing is we're first running a similarity search, right? So we're taking the user's query, and for example, if a user's query mentions retirement benefits, the word retirement doesn't even need to exist in that PDF. But if it's matched semantically to some other things, for example, 401k, it will find a match, right? So first we execute a similarity search. We find the closest semantically matching records in that vector search database. We're then putting it as a context. We're taking those records. We're putting it as a context into a prompt, kind of in the following format. We're also including the question in there, and sending that whole prompt to an LLM to write an answer, right? To write an answer in natural language.
Where does the information that 401k and retirement are related reside? Is that in LLM? Is it in the vector database already somehow?
In a vector database. In a vector database, because let's say an OpenAI model would have no clue about your company's specific proprietary information, right?
But it would know that 401k and retirement are related words.
Correct. Yes. Yeah.
So before you insert the data into the vector database, it gets those embeddings from OpenAI, right?
Yeah. So there's kind of different. So I showed you there's quite a few different vector databases, and they all have a slightly different vision how these databases should be used. So with some of them, you're passing it a chunk, right? A sentence, a paragraph, maybe even a full page worth of content, and you're generating an embedding off of it. And some databases let you store both the original content and the embedding. Using some other vector databases, you would only store the embedding, and then you would store some sort of an ID, which you can then use to retrieve the original data, right? So for example, you could store the original data in, I don't know, MySQL database, and then use one of those vector search databases just to store the embeddings and the IDs pointing back to that MySQL database, right? Or in whichever table you're storing that data. All right. So next thing are chatbots, and basically chatbots are kind of like an interface into some service or some data. Why you would use chatbots? A lot of times they're trying to improve the UI, increase engagement, kind of guide the user through the information retrieval and/or collection, and also kind of for more like traditional business process automation. So there's this project that a fellow contributor had created, which lets you kind of create like a debate between two different language models. So in this case, we're getting Google Palm to debate out OpenAI, and there's some code directly from the project, and I'll kind of show you a demo here as well. Are you guys able to see it? I think this is a bit larger, right?
Yeah, I can see that one.
Okay. So you can see it starts out with setting the topic of the conversation, set the topic of a conversation by providing the first message. And in this case, I just wrote out universal basic income. You can get them to debate out like much spicier topics. And they just kind of go back and forth, you know, weighing in on the arguments for universal basic income, arguments against universal basic income. I would kind of encourage to play around, and it gets entertaining. I find that unlike people, they tend to be very cordial and very nice, and not very combative. So the next thing I wanted to talk about are the experimental agents in the project. And what are agents? Agents are basically autonomous general purpose LLM powered programs. There's a ton of emergent research in the space, chain of thought, tree of thought, reasoning plus act, and these are all full-length research papers. They could be used to agents could be used to automate workflows or execute multi-step tasks. I find that they work much better with powerful LLMs, and they're driven by carefully engineered prompts. And also, my personal opinion is they don't really work that well. And if you're going to make them work within your application in a production grade system, they'll usually require a lot of air handling and constraints around them to account for all the fringe cases. And they can also use tools which are basically API wrappers, and it's very similar to OpenAI plugins. Some of the tools we have, and it's super easy to add new ones, are the calculator, the Wikipedia API, Google Search, Weather API. You can also connect it to your own database. Sorry, I'm just moving this menu over. So one agent that we have in the project is called a React agent. And this is the prompt that it uses. So this is a set of instructions. And basically, the goal is to get a large language model to fulfill or answer a user's question by calling into various available tools. So this section right here is dynamically generated. And these are the tools that I showed you in here. So we tell it about the different tools that it has access to. So for example, we're telling it that it has access to a search engine. And it's useful when it needs to answer questions about current events, because, for example, if you're using OpenAI, it's only trained up to on data through 2021. Where we tell it that it has access to the calculator, and that if it needs to execute some sort of mathematical expressions, it can call into it. And we ask it to generate these thought action input chunks if it needs to call one of the tools, right? So for example, you would pose it a question, it it would have a thought that I need to use a search tool. So it would say action search, action input, the input to that action. And we execute those actions on the LLM's behalf by basically either calling the search API or the calculator. We would then take the result and then send it back kind of for a second round or third round n number of times as an observation to the LLM. So let me illustrate how it works. So you could see that I'm instantiating the weather tool, the Ruby code interpreter tool, the Google search, the calculator, an LLM instance. So in this case, we're using OpenAI. And I'm instantiating the React agent. So I'm saying Langchain agent, right? Namespace, React agent, .new. We're passing it the LLM. It's OpenAI in this case. Like I said, agents work best with powerful models. I've also used it with Google Palm. It works great. There's a bunch of other ones that are powerful enough. And then we're passing it the list of available tools. So we have an instance of our agent, and the first thing I'm asking it is to find the current weather in Boston and Washington, DC, and take an average. So as it's thinking through it, it decides that it needs to find the current weather in Boston, Massachusetts. In its response, it would say action weather, action input Boston, Massachusetts. We're taking that string, we're passing it to the weather tool and executing that query. So you could see in over here, we're calling into the weather tool and we're executing to find out the current weather in Boston, Massachusetts. We're taking that result and sending it back to the LLM. The next thing is that it decides that it also needs to know the weather in Washington, DC. So the response it generates, it says action search, action input, Washington, DC. We're taking that string, we're sending it to the weather channel, executing it on the LLM's behalf. We're getting an answer back and sending it back to the LLM. So in this case, at this point, it has current weather for both Boston and Washington, DC. And the last thing, because we asked it to take an average, it produces an action calculator, action input. Here's the action input that it produces, which is the weather from Boston plus the current weather in Washington, DC divided by 2. And we're calling into the calculator tool, sending it back the result, and then produces the final result, which is the average temperature in Boston and Washington, DC is 84.2 ... degrees Fahrenheit. And a little bit below, if you could see on my screen, the next question that I'm asking is, what is the current ruble USD exchange rate? Sorry, let me reverse. Yeah, so you and of course the LLM doesn't know the answer, right? Doesn't know the current exchange rate, right? So it needs to call into this. It needs to use the search tool to find the current exchange rate. So it produces the response that it comes back to the original prompt, to this original question, is it says action search, action input, ruble USD exchange rate. We take that string, we send it to our Google search tool, execute that query, get the response back, send it back to the LLM as the second prompt, and it then produces an answer. And I'm not sure if you see it, but all the way at the bottom it says 1 ruble equals 0.011, etc. USD. And lastly, because we told it that it can use the Ruby interpreter, Ruby code interpreter, we're asking it to use a Ruby program to output the sum of the Fibonacci sequence for 1 through 1000, and do not define any Ruby methods. And it again produces an action. It says Ruby code interpreter tool. It produces the action input, and the input is this one-liner. We're then taking that string, we're executing it within a Ruby code interpreter, and sending it back the answer to kind of synthesize a natural language response. So we send it back the answer, and it says the sum of Fibonacci sequence for 1 through 1000 is what is this? 9,000. Yeah, I'm sorry, 998,000. The next tool that I wanted to show is the SQL query agent. You could see that I'm instantiating a database tool and passing it a database, a Postgres database that I have that I'm running locally. Again, we're using OpenAI in this case. We're instantiating the agent, so I'm saying Langchain agent namespace SQL query agent class .new. We're passing the LLM instance. Well, reinstantiating it, but we should have just passed the instance here. And we're passing it the database instance. When this happens, we actually kind of run a reflection on the database just to look at the schema and all the tables and whatever columns, and kind of trying to get the database schema. And once we have the instance of that agent, we can ask it different questions about the data in our database. So you can see in this case, I'm asking how many users are there. And it again produces the same action input pair. So it says action database, action input, and it produces the database query that we're going to execute on its behalf and send back the answer yet again. So in this case, it produces a query select count star from users, and we're taking that query, we're using the database tool to execute that query, and then we're sending it back to the LLM. And the final answer is there are 2,589 users. The next question that I'm asking it is how many users have completed all 4 courses. And my apologies, I should have mentioned this locally. This database that I have running locally is actually is an e-learning application, is a database from an e-learning platform. So it has a users table, it has a courses table, it has a certificates table. So as users are completing courses, they're earning certificates. So I asked it how many users have completed all 4 courses, because that was the number of courses available in the application. And the query that it produces is select count star from users, inner join certificates on users.id equals certificates.userid, right? So it does the inner join between the certificates and the users table. And then the additional clause is also that the certificates dot complete equals true. And we're taking that query, we're executing it via the database tool and the LLMs we have. We're sending it the result back. Not exactly sure why I chose that query, this specific query to execute. And you can see at the bottom, the answer is 160 users have completed all 4 courses. And then lastly, we're asking how many users have opted out of email notifications. Oh, sorry. And the query that it produces is select count star from threaded notifications for follow topics. We're using the threaded open source form library, so hence the name of a table. And it responds back with 157 users have opted out of email notifications. So it doesn't just make up that data. It uses the database tool with our assistance to execute the query and then send it back to the response. Okay, so what's next for Langchain.rb for the project? So we want to make sure that we're building this tool with actual use cases and it's rooted in real needs. So we're collecting any and all feedback, constructive criticism, or non-constructive. Super open to any feedback. We're trying to sharpen kind of the full end-to-end flows. Like one of the end-to-end flows I've shown you was instantiating the vector database and just pointing it to files that you have locally in some folder, and then parsing those files, importing them, and being able to execute queries on top of them. Some features we're working on are bringing better observability in terms of what's actually happening, the analytics in terms of some of the associated costs, like how much do some of those prompts will cost you to execute. As you know, OpenAI charges you for the number of tokens passed in. We'd like a deeper integration with Rails, expanding into kind of into adjacent areas, either more on the full stack side, or more into kind of going deeper into the different AI ML tools. We're working on the caching layer as well. There's some really good references and reads here as well. The rise of the engineer article. What is vector search? I know I kind of glossed over the one about word and sentence embeddings, and that's it. Yeah, super open to contributors, any ideas, constructive criticism, and you can use the QR codes either to join the Langchain.rb Discord channel or Discord server, or just look at the slides again. Please feel free to reach out to me. I'd love to learn about what kind of work people are doing in the space.
Awesome, thank you.
Yeah.
Thank you.
Do you have time for a few minutes of Q&A?
Yeah, definitely.
Cool. Yeah, so I did get a little bit of time yesterday to play with it, and one of the things I was pretty curious about, and maybe this is one of the observability growth plans, but like it'd be cool to be able to set like the log level to be able to see like exactly what it sends to the LLM and like when it sends stuff to the LLM, because it's like, yeah, I wasn't really sure when it was making calls and how much certain things cost me and things like that. Is that a road plan? Like, could there be like a log level where I see exactly the prompt it sends to the LLM, or would that be like too much?
No, I think it's a great idea. Right now we're just right now. So for example, I showed you the agents, and I mean I have a difficult time explaining how the agents work, because a lot of times, like if for folks that are like not familiar, that for folks that haven't caught up with all the recent developments, like it may just seem like magic, right? So I have a hard time even explaining how it works, because there's so much kind of prompt engineering, or prompt hackery that empowers this functionality. So right now we're just outputting like all the steps that are happening. The LLM has a thought, then we're executing the tool, then we're sending it back to the LLM. But I actually do agree. I think we need to do we need to go one step further, where in your debugging efforts, you can see the actual prompts, right? So we're sending this prompt, and then the tool produces this result, and then the updated prompt is this, and then this is the number of tokens that we're sending to OpenAI, for example. So you do that, okay?
Yeah, we do that at work.
Yes.
We put the prompts and the number of tokens and stuff on the open telemetry traces as attributes.
Oh, nice. Yeah, so I would be all for it. I'll be all for it. Good question.
Hi, this is Chris. I have a question. Are there any open source self-hostable large language models that you would actually use for anything? Or if there aren't, where should I keep an eye out for where those might appear?
So I believe the most powerful one currently is the Llama 2, which was just released by Meta. You could run it on your computer pretty easily. It is slow. I mean, I have a fully loaded M1 Pro, MacBook M1 Pro, and it's still pretty slow. From kind of the benchmarks I've seen, the performance is similar to that of GPT 3.5. So the closed source models are still the most powerful ones. But I would suggest taking a look at the Llama 2.
Okay.
So yeah, let me see. Oh, whoa. Why can't I use my browser? Okay, so there's actually this Ruby wrapper, and we actually Langchain.rb actually does integrate with it as well. So there's a Ruby wrapper to be able to call into this locally running Llama model, and then this is the original. This is the Llama C++ implementation, and I mean, you just need to look through all of this, and it takes a little bit of time and kind of hacking together to get it up and running. There's also this project called Ollama.ai, which is basically a Mac OS X desktop application. Dead simple. Let me see if I actually have it. Later. it's kind of a just really simple UI layer on top of it. Hmm.
And then one other question slash feature request is, once there's that other tool that will let you take a prompt and then a set of outputs, like example cases, and it'll build out an ELO rating system for a bunch
It
of
will it will build out what?
it'll generate a bunch of different prompts and then rank them by ELO against each other. So it'll like, you can use AI to generate the best prompt for a given set of sample data, or like one of the AIs, whatever large language model. So
Oh, interesting.
the feature request for here would be, once you can tag, like when your system's doing things, when you have your agent off doing stuff, if you could tag every time it does a thing where you're like, yeah, that was right. And then you could later take this other tool, go back with all your examples and maybe like reduce your token usage or whatever. Just sort of automatically have that run in the background every so often.
Right. I like that.
I'll send
Yeah,
you a link
interesting.
because I don't remember what it's called, but I've got it bookmarked.
Please do. Yeah, so this so the React agent, let's look at the prompt here again. So the React agent kind of implements some things from this paper called the chain of thought. And there's the next iteration on top of the chain of thought was tree of thought. And basically the way it works is that as you're using an agent, and the LLM produces a series of next steps, right? Of like intermediary steps of getting to fulfilling your request or fulfilling or answering your question as it's producing the next steps. If you were to implement the tree of thought research, it would produce multiple permutations, and you would then also ask it to pick the best.
Ooh, we lose connection there. Just a quick heads up until your connection back. We have to be we have a hard deadline at 7:30.
Right, so it's kind of
we lost you for like 5 seconds.
Oh, sorry about that.
But I was just telling them that we have like a hard deadline to be out at like 7:30, so we can go for
Okay.
like 5 more minutes and then we should probably
Sure.
wrap up. Any more questions? I do have a question, but if anyone else has a question. All right. So for like the similarity search, one of the parameters is K to get the number of results to be retrieved. Why K? Like I'm just like thinking about the API. Like why is that parameter K?
Why is it K versus like an N?
Yeah, or just like I was wondering if like maybe I didn't totally like, so the number of results retrieved, I would expect that to be like I don't know, like count or length, but I'm just kind of curious. K means something in like the AI world or in some world that I don't know about. So like K means clustering kind of thing, or
yeah, the cave near Samber, yeah.
okay.
But I actually got that. So there's some novel approaches here, but I have looked at a ton of different projects, and certainly the original Python Langchain implementation, and that was just the name they called that parameter. So I stuck with it. And I will just say if I can mention one thing, that while the project has been inspired by the Python implementation, there's a lot of anecdotes on Hacker News, and people have written kind of blog posts about Langchain being over engineered and having too many abstractions. So while the original idea is from the Python project, I'm really hoping that we can put a Ruby spin on it. Again, I've mentioned this level of pragmatism that Ruby developers tend to exercise. So I've really been hoping that we can avoid stepping on the same brakes that a ton of these projects do.
Yeah, I saw some of those articles, and I was like, kind of went into it a little bit skeptical, but after playing with it, I feel like the Ruby and Rails world is going to be way more receptive to something like this.
Yeah, right.
Kind of on that, thinking about that graph of like the AI data scientist who writes everything themselves and like has maybe never worked on like a large application that powers a product versus like your typical Ruby developer who does. I feel like we are kind of like more receptive to this kind of thing.
Yeah, I agree.
Oh yeah, we're getting close to our deadline. I do have other questions, but I might make them in the form of pull requests. I'm going to continue with it. It's very cool.
That's perfect. Yeah, issues, discussions, pull requests, Discord conversations. Yeah, please feel free to email me, tweet at me, add me on LinkedIn. Really curious about what everyone else is doing in this space.
Awesome. Well, thank you everyone who came virtually and in person. And I would say this was a success. And,
Yeah, absolutely.
Yeah, I'm gonna go out. Thank you all. Thank you to our
Thank you so much. Thank you for having us. Thank you.